So at the top of your notes here, we have that little paragraph, okay? When you know the vertex and a point on the parabola, when you know a vertex and the point on the parabola, you can use the vertex and the point to write the equation in vertex form. We've done that before. We plugged the vertex into vertex form for the h and the k values. We plugged the point into vertex form for the x and the y values, and then we solved for a. And then once we had a, we plugged a and the vertex back in, and that was the equation of our parabola in vertex form. We've done that. Well, what if we don't know the vertex? Okay? If we don't know the vertex, we can still write the equation of a parabola, but we now have to use standard form, and we have to have 3 known points. Okay? We don't know if any of them are the vertex, but we have to know 3 known points. Okay? So, let's dive in and see a situation like that. So looking at number 1, your first example here. We know that a parabola contains those 3 points. We want to know what is the equation of the parabola in standard form. So the very first thing you should do is you should be writing down what the heck is standard form.
It is y equals ax squared plus bx plus c.
Yeah, y equals ax squared plus bx plus c. That is standard form. So in order to write this equation, we need to find out what is a, b, and c. Now, looking at the 3 points that are given to you, do any of those jump out as you as something special?
0, 0.
0, 0 is what?
Vertex.
Nope. 0, 0 gives us the y-intercept. How do I know? Because the y-intercept in standard form is always located at 0, c. If the x-coordinate is 0, that means that point is on the y-axis. That is the y-intercept. So we immediately know by looking at the points that our c value is 0. I'm going to put a box around that because we're going to need that later. Okay? We're going to need that value later. All right, so next, I want to keep my work organized. Okay? I want to keep my work organized. So I'm going to name this first point just point number 1, and the second point here as point number 2. You can name them point A and point B. You can name them Fred and George. You can name them whatever you want, but you got 2 points. You want to keep them separate from each other. So I'm just calling them point 1 and point 2. Okay? I want to use point 1 to write an equation. And I'm going to call it E1 for equation 1. Keeping my work organized. For equation 1, I'm going to plug point number 1 in as x and y into my standard form equation. So negative 2 equals a times negative 1 squared plus b times negative 1 plus c. But what's c? 0. So plus 0. Okay? Well, now we want to simplify that down. So, we get negative 2 equals, negative 1 squared is 1 times a is a. B times negative 1 is negative b. Plus 0 goes away. So there's equation 1. Now we want to find equation number 2. We want to use that second point up there. We want to plug it in. Okay, so that second point again gives us an x and a y. So 6 equals a times 1 squared plus b times 1 plus, again, what's c? 0. All right, so simplifying this down, we get 6 equals 1a plus 1b. Okay? Now, this is a callback to your Algebra 1 days. You guys learned in Algebra 1 that if you have one equation with just one unknown, say like x, you can solve for x. Right? That was a big part of Algebra 1. Now, you guys also learned in Algebra 1 that if you have two equations, for example, if I have one equation here that says 6 equals a plus b, I can't solve for a and b in that just one equation. Right? Because there's too many possibilities. It could, a could be 4, b could be 2, a could be 5, b could be 1, a could be 7, b could be -1, right? So we can't solve for a and b if we just have one equation with two unknowns. But we can if we have two equations with those two unknowns. And that can be expanded out as far as you want. You can solve an equation with 7 unknowns as long as you have seven different equations that work with those 7 unknowns. You have to have an equal number of equations as you have unknowns. Okay? So we have 2 equations with 2 unknowns. All right? So we're going to use those to solve for a and b. This is called a system of equations. So to write as a system of equations, I go through and I draw a brace. I draw a brace and I write my first equation on top, second equation on the bottom. Okay, so we have our system of equations written together. That means we want to solve for a and b in these 2 equations at the same time. All right? Back in Algebra 1, you learned 3 different methods for doing this. One method was that you guys graphed these. These are linear equations. And so you guys graphed these and saw where do your 2 lines cross, and that was your solution. The problem is that's not very accurate because what if your lines cross at fractional coordinates? Okay, on our graphs, there's no way for us to tell what those fractions are. So that's a bad way of doing it. Another way you learned was called substitution. And in substitution, you took one equation, for example, you took that bottom equation, 6 equals a plus b, and you would say subtract b from both sides. So now you have 6 minus b equals a. And you would substitute that 6 minus b in for a in the other equation and then solve for b. It can be done that way. It works every time, but it's very labor intensive. Okay, very labor intensive. That's called the substitution method. Very labor intensive, a lot of paper and pencil, a lot of algebra involved. Okay, so there is the third method that you learned, which is my preferred method, so that's the one we're going to learn in here. Okay, it's called the elimination method. Okay, elimination is basically just what it sounds like. You're trying to eliminate a variable. Okay, and to set up this method, what you have to do is you have to write your 2 equations like we have here as a system, and you got to make sure they're written in the same form. It doesn't matter what form, just as long as they're written in the same way. Like here, I've got a number, I've got an equal sign, I've got an A, I've got a B. They're written in the same form. They're all lined up. Okay? The next thing you're looking for is at your variables. Look at your variables here. So I got my A's, I got my B's. Notice that the B's are a different sign. One's positive, one's negative, right? Also notice that the coefficient, remember the coefficient is the word we use for the number out in front of the variable, right? So notice that the coefficient of our B's is the same number. The top one is a -1, the bottom one is a +1, right? That's what we want. We want them to be the same number, but opposite signs. The reason for that is because to use elimination, what we're going to do is we're actually going to add these 2 equations together, just in their column. So we're going to take -2 plus 6. Bring down the equal sign. We're going to take A plus A. 2A. We're going to take -B plus B. They cancel away. -B plus B is no B's. Okay? So now we have 4 equals 2A. Notice we have eliminated a variable. That is why this is called the elimination method. So we now want to go through and divide by 2. And A equals 2.
Is that the final answer?
No. This is not the final answer. We've only solved for A and C. We still got to find B. Okay? And to find B, notice we have two equations that have only a and b in them. Equation 1 and equation 2 have nothing but a and b in them. We found what a is, so plug a into one of those two equations. I think equation 2 is going to be the easiest. So I'm going to go ahead and plug in to equation 2. And again, I like to write equation 2 to keep my work organized so I know where I'm getting these numbers from. Okay? Well, equation 2 says we have 6 equals a, which is 2, plus b. Subtract 2 from both sides. 4 equals b. So now we know all three variables, a, b, and c. So we can go ahead and plug it into standard form to write the equation of our parabola.
Wait, if you plugged
2x squared plus 4x plus 0. I don't need to write that part. So there's our equation. So in our second example, we know that that first point, 0, 0, is the y-intercept because the y-intercept is always located at 0, comma c for standard form. So therefore our c value must be 0. Okay? Well, now we want to use our first point here. I'm going to call that equation 1. And I'm going to plug that point into standard form. So I get negative 2 equals a times 1 squared plus b times 1 plus 0. Where did I get that 0 from? That's what c is. That's what c is. So we simplify this down here. We get negative 2 equals a plus b. All right, let's look at equation 2. Equation 2, plugging that in, that's from point number 2. So therefore, y is negative 4 equals a times negative 1 squared plus b times negative 1 plus 0. And again, that 0 came from the c value that we already know. Simplifying that down, negative 4 equals, negative 1 squared gives us what? 1. So I have 1a, and then b times negative 1, negative b plus 0. Okay, so we're set up now. I want to write my system. So I have negative 2 equals a plus b, and negative 4 equals a minus b. Notice here that in our system, the b's are already set up to be canceled. Right? They're already set up, so that makes us happy, so that's going to be pretty easy. We want to go ahead and add these equations together. So I get negative 6 equals 2a, and the b's cancel away. So to solve for a, divide by 2, and a must equal negative 3. All right. So, Dre here said we want to plug into the first equation. I agree. You could have also plugged into the second equation. Doesn't matter. But if I plug into equation 1, that means I have negative 2 equals negative 3 plus b. Because remember, I'm plugging that value we found for a, and I'm plugging it in for a in that equation. So add 3 to both sides. 1 equals b. So we have now found all three variables a, b, and c, so we can write our equation. Oops, wrong color. That's all right. So y equals negative 3x squared plus 1x plus 0. So there's the equation of our parabola. All right, if we take a look at number 4 from your homework assignment that I just handed out, let's try this one together. So, starting out, we have our 3 points. I want to write down standard form. Are we able to tell a variable a, b, or c? C. As in the letter C or yes?
Yes.
Yes. Okay. C. So what is it? C is negative 10. Because this is our y-intercept. So that gives us the C value.
How do you know it?
Because the y-intercept is always at 0, comma C. So if there's an x-coordinate of 0, then that y-coordinate is our C value. Okay? So next, we want to plug in point number 1 to make equation 1. So that gives us negative 4 equals a times 4 squared plus b times 4 minus 10. I want to go ahead and add 10 to both sides. So I get 6 equals, well here I've got a times 4 squared. 4 squared is 16, so I have 16a plus 4b. All right, well I need to go through and write equation 2. So I'm going to use that second point that I haven't used yet. So I have negative 6 equals a times 1 squared plus b times 1 minus 10. Where am I getting that minus 10 from? That's our C value. Yeah, I'm plugging that into standard form. So I'm going to add 10 to both sides. So 4 equals a plus b. Okay. So I have this. I now want to go through and write my system of equations. So I have 6 equals 16a plus 4b. And 4 equals a plus b. This is a situation where our system of equations is not yet set up to be eliminated. Because of the numbers, because A's don't have the 1 positive, 1 negative in the same number. B's don't have 1 positive, 1 negative in the same number. So what we need to do then is we first need to decide which variable we want to eliminate. So I'm going to go ahead and pick B. I want to eliminate the B's. So in order to eliminate the B's, I see here that I have a positive 4B. What could I multiply this by to make it a negative 4b?
Negative 4.
I got to multiply by negative 4. So if I multiply this entire equation by negative 4, all right, my first equation stays the same. But the bottom equation, I have to distribute negative 4 all the way through. Everything gets multiplied by negative 4. So I have negative 16 equals negative 4a minus 4b. Now we are set up for elimination. If I add these together, I get negative 10 equals 12a, and the b's cancel away. We can now solve for a by dividing both sides by 12. So a equals, let's see, negative 10 twelfths. That reduces down. Negative 5/6. There's our a value. Okay? Now that a value, I got to find my b value, so I'm going to plug that back in to one of my equations. I think equation 2 would probably be the easiest. All right, so if I plug that into equation number 2, that is 4 equals a is negative 10 twelfths, and that plus b. I don't know why I went back. That's a great question. We said that was negative 5/6. Just checking. Just checking. Okay. So we need to go through and add 5/6 to both sides. So that means we need to have a common denominator of 6. So 4 is the same thing. What's 4 times 6, by the way? 4 times 6 is 24. So that's the same thing as 24 sixths plus 5 sixths. That's just 4 plus 5 sixths. Okay? So adding those together gives me 29 sixths.
Okay, and now a dumb question. Why don't you want them?
Finishing our problem here, we now know A, B, and C. So the equation here is going to be y equals negative 5 sixths times x squared plus 29 sixths times x minus 10. There's the equation.